Jake Lewington here at HPE Discover, and I'm here with Richard Lewington. And behind us we have a series of white balls connected by green rods. And can you explain what that is and why it's there?
Sure. This is an interactive light exhibit that we made for South by Southwest this year to illustrate the computing principle we call distributed mesh computing.
Okay, and so what makes this a representation of distributed mesh computing?
Right. So each of the balls is a node, so a thing. And the green lines indicate the pathways of communication between them. And what you might notice that's different here from a classic IoT model is that they're connected to each other and not just connecting back to the cloud.
So it's not just a series of dumb devices that are all sending data back in a stream, it's something different.
Honestly, when most people talk about the IoT, they're really talking about the cloud. Because the endpoints, the nodes, don't do anything. They have no intelligence. They just send their data back to the cloud, and the cloud decides what to do with it, and back comes some kind of instruction.
So how is this better?
Well, if you think about a sensor like a video camera, it's got a tremendously large video stream, tremendous amount of data, megabits a second going back to the center, to the cloud. But most of the time, that's not really what you want to know. Imagine a security camera outside your house. All you really want to know is everything okay? And then, if the answer is yes, then you've reduced 5 megabits a second to about 5 bytes. So you massively take the load off the communications infrastructure while actually making the information more useful. Because you had the cloud hasn't had to decide whether what it's saying is bad or not.
So how does the node at the edge become smart enough to know whether things are okay in that security scenario?
The trick is to give it enough processing and memory, more importantly, a large amount of memory, so it can learn what's normal. It knows its entire history, everything it's ever seen, and so it can see if something's anomalous or normal. Now, this is not an easy thing to do, and that's why it's part of our machine project, where we can put a large amount of non-volatile memory, persistent memory, and enough processing power in every node to allow it to do that.
Doesn't that get prohibitively expensive at some point?
Well, our plan is that the cost of high-density, low-cost, persistent, performant memory is going to plummet precipitously over the next few years, to the point where it becomes economically easy.
So you get into the neighborhood of cents per device or something like that?
Right. And depending on the device, you might need megabytes to store its own history if it's a simple on-off sensor, or you might need terabytes if it's a video camera, say. But we can certainly see a future where that becomes trivial. After all, look what's happened to the cost of memory in our lifetime.
That's true. It's gone way down.
Right.
So, I mean, security is a good example, because I mean, you can have things like, is it the dog walking around the house, or is it actually some unknown person walking around the house?
Right.
But what would be another kind of smart use case for this sort of node configuration?
Well, one of the ones we've thought about a lot is a connected car scenario. And it's very, very useful for cars to be able to communicate with each other rather than go back to the cloud, partly because of what I was talking about, bandwidth, but also because of latency. If some hazard appears on the road, you want to be able for cars to communicate to other cars very, very quickly that something's going on. If we take the time to go all the way back to the cloud and back, something bad could have happened. So it's a safety implication.
So how far out in the future is this? Is this a reality next year? Is this a reality 5 years?
If you look at what HPE is doing as a whole, our edgeline servers are moving compute closer and closer to the edge. And our ultimate end goal with the machine is to bring it all the way to the edge. Now, our goal for the machine is to make this mainstream by the end of the decade. So those are the kind of timescales we're looking at. But we already have prototypes of small sensor-laden computer nodes using conventional off-the-shelf hardware that we will gradually replace with more sophisticated hardware as it becomes available.
Very cool. So it's in the future, but not too distant future.
That's the plan.
All right. Well, thanks, Richard.
My pleasure. Anytime.